Good afternoon. Good afternoon, students. Hi, Sama.
Good afternoon, sir.
I am fine. Let us start our today discussion. Our today discussion is focused on new chapter or chapter 3 about pressure. Pressure. Do you know before what is pressure? Pressure is what? What's pressure? The term pressure shows. What's pressure? No one? Pressure is
an effect which occurs when a force is applied on a surface.
okay. Pressure is occur when a certain force or force F is applied on a given or a unit area. There is area. Okay. There is pressure. Okay. There is pressure. You remember we have seen in our previous time about area, about force. So the combination or the division of force divided by area gives for you what? Pressure, okay? Pressure. Therefore, pressure is when a force F applied on a surface area of 1 unit, we will get what? Pressure, okay? We will get pressure. So definition of pressure is the force acting on a unit area, okay? The force applied on a unit area is what we call pressure. The symbol of area is P. The symbol of area is P. Therefore, P is equal to F over A. From this one, force is equal to pressure times area, and area is equal to force over what? Force over pressure, okay? Force over pressure. So if two of them is given for you, you can find for the third one. The other one is the SI unit of pressure. The SI unit of pressure is what we call Pascal. Pascal means 1 Newton per meter cube, not meter square. 1 Newton per meter square. For example, from this one, Newton is from the SI unit of force, and the meter square is from the SI unit of area. Again, from this one, 1 Newton is equal to Pascal times meter square. Okay. If you remember in our previous time under Newton's third law, 1 Newton is equal to kilogram meter per second square. Okay. So don't forget what we have seen in our previous time. Don't forget, they do have their own relation. Okay, they do have their own relation. So don't forget, they depend on each other. There are non-SI units of pressure like millimeter mercury or millimeter of mercury, centimeter of mercury, millimeter mercury. Hg represent, for example, Hg. Hg is the symbol of what? The symbol of what? Hg in your chemistry concepts. Hg is what?
Mercury.
Mercury. Therefore, there are none SI units of pressure like millimeter mercury, centimeter mercury, bar, millibar, and torr. Okay, these are non-SI units of pressure. Non-SI units of pressure, and they do have their own relationship. Okay, for example, 1 millibar is equal to 100 Pascal. 1 millibar. 1 millibars means when we equate or when we compare with Pascal, this is equal to 100 Pascal. 100 Pascal, and then 1 bar is equal to 1,000 100,000 bar. Have you seen the relationship between them? Therefore, for example, you can see from this like table, 1 millibar is equal to 100 Pascal. For example, 1 bar means 1 bar is equal to uh, 1000 millibar, millibar, 1000 millibar. If 1 millibar is equal to 100 Pascal, 1 bar is equal to 100,000 Pascal. Okay, 100,000 Pascal. So depending on this relation, we can find the relationship between them, or we can uh, change, or we can change to each other. Okay, we can change to each other. Therefore, one Thor, for example, one Thor is equal to 1 millimeter mercury, which is equal to, for example, look the relationship between this one. When you change 1 millimeter, 1 millimeter into 1 millimeter into centimeter, you will get 0.1 centimeter. Mercury is mercury, no problem. Therefore, 1 millimeter mercury is equal to 0.1 centimeter mercury. When we equate, okay, when we equate, or when we compare this one, the relationship between them is 0.1. This 0.1 is comes from the relationship what we have seen in the relationship of units of length. Okay, the relationship of units of length. The other one 0.1 1.01 bar is equal to 1.01 bar is equal to 1010 bars. Okay, have you seen this one? For example, have you seen? Look, 1 bar is equal to 1000 millibar. What about 1.01 bar? Have you seen this one? You multiply crisscross. Therefore, 0.01, or your question mark, is equal to 1.01 bar. Okay, 0.01 bar times 1000 millibar over this 1 bar. Bar cancel by bar, this 0 cancel, and again this 0 cancel here. You will get 1010 millibar. Okay, millibar. Therefore, this one is comes from the relationship above what we have seen. Okay, what we have seen. 0.01 bar is equal to 1010 millibar. 1.01 bar is equal to 760 torts. 1.01 bar is equal to how many Pascal? 1000 1001 101,000 Pascal. Okay, 101,000 Pascal. Again, you can change this one depending on the relation given above. And what you must know about the standard atmospheric pressure. The standard atmospheric pressures are all of these one are standard atmospheric pressure. Okay, standard atmospheric pressure. For example, 1.01 bar, 1010 millibars, 760 torrs, 101,000 pascals are the standard atmospheric pressure. Okay, the standard atmospheric pressure, because of they are equal. Okay, because of they are equal. Okay, the other point what you must know under pressure is derived and scalar physical quantity. When we talk about derived, it is not measured directly again, or it is measured indirectly. When we talk about scalar, it has no direction. Okay, it has no direction. Therefore, this is what you must know about pressure. And the other point, what you must know under pressure, the relationship between force and area, the relationship of pressure with force and pressure with area. For example, pressure is directly proportional with force and inversely proportional with what? With area or surface area. That means pressure is increased as force increase, and pressure is decreased as force decreases. Okay, as force decreases. For example, from this point, pressure is derived in the scalar physical quantity, what we have phrased above, and the bigger applied force, higher pressure. Okay, the bigger force, applied force, higher pressure, and the smaller area on which the force is applied, again the bigger pressure, and the bigger the contact area, the smaller pressure. That is, or this shows, pressure is directly proportional with force and inversely proportional with surface area or area. For example, pressure is directly proportional with force, and pressure is inversely proportional with area. Okay, that means as force increases, pressure increases. As force decreases, pressure decreases. And as area increases, pressure decreases. As area decreases, pressure increases. So we can conclude this one: directly proportional and inversely proportional. You know what is directly proportional and inversely proportional in this case. The other point, the dimension of pressure is equal to ml minus 1, the power of minus 1, and t the power of minus 2. You know what this dimension means. For example, pressure is equal to force over area. From this one, to get this dimension, force is the SI unit of force is kilogram, or the SI unit of forces, you can say Newton or meter per second square, over the SI unit of area is meter square. So 1 meter cancelled by 1 meter. Okay, 1 meter cancelled by 1 meter. Therefore, kilogram is represented by capital M. That means the dimension of mass. And this M, or the dimension of meter, is represented by L. Therefore, because of this, as denominator, it becomes by the -1. Again, this one is pair. Okay, S is the dimension or the SI unit of t. Therefore, the SI unit of the decimal, or the dimension of t, or time, is equal to twice. Therefore, we will get from this expression. Okay, we will get from the dimension of force is calculated, or come from this one. Okay, so under this point, what you must know, the what is pressure means, how we can calculate pressure, what's the relationship between pressure, force, and the area, and the dimension of area, as well as pressure is derived physical quantity, as well as scalar physical quantity. Okay, scalar physical quantity. If this point is clear for you, let us proceed to. Yes.
Can we use force, use mass times gravitational acceleration as a force?
Okay. Instead of force, can we use mass times gravitational acceleration? Your question is this one?
Yes.
Okay. Under this one, we can use, instead of force, weight. Okay. In what? For example, free falling body. Okay. In case of free falling body, And for example, if you take weight is a form of force, okay? A form of force. Therefore, in free-falling body, when we calculate force, we can use instead of force weight, okay? That means mass times gravitational acceleration. Have you understand what I have said?
Yes.
Okay, thank you. Let us proceed to examples. Example one. I think it is clear for you. A 200 Newton force is exerted on an area of 4 meters. What is pressure? Try this one. What is pressure? I think this one is very easy for you. Try it. Yes. The question is visible, I think. Visible or not?
Yes.
The question is visible?
Yes.
Yes.
Okay, try it.
Newton square.
How many? How many? 50
Newton square.
Newton per
Meter.
meter square. That means what?
Meter.
That means what? Newton per meter square means?
Pascal.
Pascal. Okay, let us see together. Force is equal to 200 Newton. What about area? Area is equal to 4 meter square. For example, area can be given for you like in centimeter, millimeter, and the others units of area. Therefore, if such question is given for you, you must change into meter square. Why? For pressure is expressed in the units of Pascal. Pressure is equal to how many? From this formula, pressure is equal to applied force over area. Your force is equal to 200 Newton divided by 4 meter square. How many? 50 Newton per meter square. But Newton per meter square is equal to Pascal, okay? So
Pascal.
50 Pascal, okay? 50 Pascal. The pressure exerted on a body on an area is 50 Pascal, okay? 50 Pascal. Clear?
Yes.
Yes.
Okay, question
Yes.
number 2. Question number 2. A 100 Newton force is applied on the surface area of 0.25 meter square. What is the pressure exerted by this force? What is the pressure exerted by this force? Find, okay? Calculate. What is the pressure?
Per minus 600 meter per
600 meter per Newton per meter square. Try.
Pascal.
600
Pascal.
or 300? How many? 600 Pascal. Okay. What about others? The same answer? The same answer?
600 Pascal.
Yes.
600 Pascal.
Yes.
Let
Yes.
us see together. It can be. It can be. It can be. Okay. What is given for you? I think you do have force. Force how many? 150 Newton. And
Newton.
what about other area? Area is equal to 0.25 meter square. The required one is pressure again. Pressure again. Pressure is equal to force over surface area or area. Your force is equal to 150 Newton over 0.25 meter square. So 0.25 means 25 divided by 100. Therefore, to omit or to cancel this decimal point, for example, what we shall do to cancel this decimal point, what we shall do? Multiply
Times 100.
times both by
100.
100, okay? Times both by
100.
100. When this one is cancelled, it will become here, okay? Therefore, 15,000 Newton per meter means, as usual, Newton per meter means
Divided by
what?
25.
Okay. Newton per meter square means is equal to again Pascal
Pascal.
divided by 25
Pascal.
Pascal. Okay, when you simplify this one by 5 how many? 5 by 5 3 3,000 divided by 5 means how many? As you said first, 600 Pascal.
600.
Okay, 600 Pascal. Thank you. 600 Pascal. So, for example, you can check your answer. You can check your answer. For example, from this one, you can check for force. Force is equal to pressure times what? Area, isn't it? The formula of force from this one, pressure times what? Area. What is your pressure? 600 Pascal. That means Newton per meter square times 0.25 meter square. Okay, meter square is cancelled by meter square. Here is when this zero cancel, you will get this decimal point comes between 2 and 5. After this decimal point cancel, it becomes 6 times 25 Newton. Okay, 6 times 25. 6 times 25.
150.
Yes, 6 times 25. How many?
150.
150 watts. 150 Newton. Have you seen? Our force was how many? 150. You can check or you can find for force again. Have you seen? This right. Do you have question on this one?
No.
Do you have?
No.
Okay, if you
No.
don't have question, let us proceed to question number 3. Question number 3. Look, how much force is required to get a pressure of 250 Pascal if the surface area is 25 4 meter square? How much force is required? Find this one. Fine, okay? Or calculators.
1000 Newton.
1,000
1000 Newton. 1000
1000
Newton.
Newton.
per meter
Okay,
square.
thank you. Yes, yes. What meter per second square? Okay. 1000 Newton. What about another? Is there another answer?
No.
Okay, the same answer? Okay, the same answer. I think let us see together. Let us see together. Pressure is equal to 250 Pascal. and the area is equal to 4 meter square. The required one is force, the force exerted, okay? The force exerted. As we have seen above, force is equal to pressure times area, okay? Pressure times area. Your pressure is 250 Pascal times 4 meter square. That means Pascal times meter square means 25 Newton, 25 Newton per meter square times 4 meter square. Meter square is simplified by meter square. So when you multiply this one, I think you will get
1000 Newton.
1000 Newton, okay? 1000 Newton. You can check again from this one, check. Pressure is equal to force over area, which is equal to 1000 Newton over 4 meter square, which gives for you 250 Pascal, okay? 250 Pascal. I think what we have seen in our today discussion is clear for you. Clear for you.
Yes. Yes.
Therefore, in our today discussion,
Yes.
we have seen the definition of pressure, how we can find or how we can calculate pressure. For example, pressure is the ratio of force to area, and we have seen the relationship between units of pressure as well as the relationship between force and the pressure as well as the relationship between area and the pressure we have seen. Okay, so try to revise by yourself what you have seen in our today's discussion. I will stop on these points. If you don't have question, enough for our today discussion. Okay, enough.
Bye.
Do you have question? Do you have question? If you don't have question, goodbye. See you
No.
next time.
Bye.